Hello, welcome. Thank you for being here. In this video, we're going to talk about the relationship between creatine and how it affects your brain. There are real benefits to be had here, but I do think that much of the discussion that you'll see online about this topic is a little misguided and a bit sensationalistic. So hopefully this video gives you a more real understanding of what you can expect from it so that you are a bit less let down from it and so that you don't spend as much money as you need to on creatine. So really quickly, this is the plan and the talking points that is scheduled for today. As always, this is not medical advice, and all references can be found in the description box. So there is an accompanying article to this video. All of the references can be found hyperlinked next to the claim they seek to support. So hopefully that makes it a bit easier for you if you want to cross-reference anything I say to the source I'm using to support it. So I do have another article and video that gives a much more in-depth analysis of the basics of creatine, but for the purpose of today, I'll just give you a brief sort of overview. So creatine is the combination of two amino acids, methionine and arginine. And just really quickly, amino acids are the building blocks that make up proteins, peptides, hormones, connective tissue, and almost everything else in your body. It is a compound that we can make naturally within our own bodies, mostly in the liver, but also in a number of other different tissues to a lesser extent. And it is also found naturally in food, mostly in things like red meat and fish. With regard to what it does, it is the energy substrate for an energy system called the creatine phosphate system. So you have three different energy systems your body can use to produce energy and fuel all the things that it does in a day. The fastest acting is called the creatine phosphate system. This energy system can produce energy very quickly, but it can't do so for very long. So as a result of this, with regard to exercise, at least, the types of activities it's going to fuel are things like sprinting, jumping, heavy lifting, things to that nature. The problem is, again, with regard to exercise, our muscles are typically only at about 40 to 60% of saturation with regard to creatine. And as a result, the limiting factor to this energy system is the amount of creatine available for energy production. So when you supplement with creatine, you seek to saturate your muscles or whatever tissue is at question. In this case, it's going to be the brain pretty soon. And therefore, you maximize the substrates available for energy production within this. And that's another point worth breaking up while we're on this topic. Creatine is not a supplement in which you take it and 30 minutes later there's an effect. It's a supplement that must saturate the tissue of interest in order for it to have its effect. So that's why, if someone starts, so with muscle, the commonly used dose is 5 grams per day, pretty much taken in perpetuity. If you have not been taking creatine and you start taking 5 grams per day, it'll take about 2 to 4 weeks-ish for the full effect to really start to set in, because that's at that dose, the time it'll take for all the effects for your tissues to saturate. But again, we have a whole other slide on dosage that we will talk about later. So let's put that on pause for now. So similarly to muscle, creatine is stored in the brain and used for energy production within the brain. And also similarly, it is not typically found at the full amount of saturation that it could be without deliberate supplementation. There are some differences with how easy it is for creatine to get into the brain as compared to muscle. So there's a structure called the blood-brain barrier, which is a sort of bouncer for the club of your brain. It selects and picks and chooses what is allowed to enter your brain from your main blood supply. Most compounds are going to require a specific transporter in order to cross this blood-brain barrier and be allowed into the brain. Creatine has one, and it is conveniently called creatine transporter 1. There is a CT2, but CT1 is kind of the main one. And the problem with this transporter is a couple things. So it is somewhat sparsely found across the blood-brain barrier. It's not very profusely available, all across its surface area. And your body tends to make less of it in response to exogenous creatine supplementation. So if you start taking creatine, your body will start producing less of this creatine transporter 1, which again is the thing that's going to transport it across the blood-brain barrier. Now, that is the rationale that you will see some people use for taking higher doses of creatine, anywhere from 10 to 20 grams per day. But I do have some problems with the basis of that recommendation, which again, we will talk about a bit later. And the general thought process behind this is that, obviously creatine will help energy production of the brain by directly providing more energy through the creatine phosphate system. And there's the thought that it can sort of take the burden off of the other energy systems. So if the creatine phosphate can handle more of the load, then your other two can not do as much work or can handle more work because they don't have to do as much as they were doing before. So in my opinion, there's one study that really catapulted the online creatine brain conversation online to, I just said online twice, but to what it is now. And that was a 2024 paper published some university in Germany. But what they did was they gave subjects a either super high dose of creatine, I believe it was 25 grams, or a placebo white powder that looks like creatine. They then kept them up all night, and at various points throughout the night, gave them these sort of cognitive tasks, challenges, memory games, things of that sort. And continually, the creatine group outperformed the placebo group. So in other words, as the sleep deprivation became more severe, the difference in how they were performing became greater, with the creatine group doing that much better than the placebo group. Another study had their subjects sit in a room with about half of the normal oxygen that is normally in the air for about 90 minutes, I believe. And again, gave a high dose of creatine versus a placebo. And then they did the same thing. The group that took the creatine did much better on various cognitive tasks and memory challenges compared to the placebo group. In people who are of advanced age, creatine supplementation has been shown to improve things like memory recall, word association, and things like that. But in people who are young and otherwise healthy and not afflicted by some sort of disease or condition, creatine supplementation has not been shown to have any benefit on cognitive function or how smart you are in general. So here's the deal with all of these studies here and all the research at large, for the most part, is that creatine supplementation will improve your cognitive faculties and your memory and things like that under conditions where it is otherwise being inhibited. So for instance, sleep deprivation is going to hinder your brain's ability to work properly. So is being deprived of oxygen, and so is being of advanced age relative to being in your 20s per se. But what it is not going to do is raise your baseline per se. So you can think of it more as an insurance policy, so to speak, which I do think is a good enough reason to justify supplementing with it for this reason, because at some point or another, we are all going to have a bad night of sleep. I think it's reasonable to suspect that under conditions of, let's say, high stress, let's say if you're in a busy period of work or something like that, that it would have a similar effect in improving cognition under those sort of conditions. But again, it's not making you smarter per se. It's just making you more resilient is a better way to put it. Something a little less talked about, equally as cool, in my opinion, is the effect of creatine on mood disorders, which really means depression. So major depressive disorder is the more accepted term for what is colloquially called depression. And this sort of condition is typically correlated with a decreased store of creatine in the frontal lobe, which again, that alone does not imply that is causing it. It doesn't mean that the decreased creatine is causing the depression. It's just that with people who have major depressive disorder, they typically have less creatine stored in that area. And the frontal lobe is really exactly what it sounds like. It's just the front part of your brain is one way you can think about it. In this population, people with major depressive disorder, creatine supplementation taken at a dose of 20 grams per day for 4 weeks or 5 grams per day for 8 weeks have both been equally, I've shown it been for raising the stored creatine in this part of the brain. Now, again, that claim right there doesn't necessarily imply benefit. In other words, that doesn't mean that their depression got better. But this last study here, there's a study, I don't off the top of my head remember the specific antidepressant that was being used. I don't believe it was an SSRI. But among a few classes of antidepressants, taking creatine with the antidepressant tended to produce better outcomes than taking the antidepressant alone. And this study here, better than these other claims up above, display some type of relationship that may be at play. To my knowledge, I do not think that there are any studies looking at creatine alone on major depressive disorder. So it's not really a hill worth dying on yet, in my opinion. But I do think there is something here, particularly because of the effect of creatine augmenting the benefit of an antidepressant, especially because these antidepressants can come with a whole host of somewhat unpleasant side effects. So anything you can do to get a better result from them, I think is very worthwhile. What's even less talked about, but still equally cool, in my opinion, and equally worthwhile discussing, is the effect of creatine on concussion, essentially. In the research, you'll see this described as creatine and traumatic brain injury, but really what people are talking about is a concussion. And if you're unaware, a concussion is an injury to the brain where the brain essentially rams up against the side of your skull and it becomes damaged upon impact. When this happens, there tends to be, one, a decrease in stored creatine in the area that was affected, and two, an alteration, at least, in the arterial flow to that area. So you're having impaired energy production from the creatine phosphate system itself, as well as impaired energy production from your other two energy systems because they need blood, oxygen, nutrients, etc., to get there to supply them with what they need. The best study that looked at this gave youth athletes who took a concussion about 0.4 grams per kilogram for 6 months. So for a, let's say, a 150-pound person, 0.4 grams per kilogram would be about 22 grams of creatine per day, which is a lot. And again, we're going to talk about dosage, I believe, after this slide, but the historically recommended dose is 5 grams per day. So 22, 4x we're talking about is not, it's not a small amount. And now there's one study in particular that I'm drawing this claim from. That's going to be found down below. There's a lot of stuff that happens after concussion. So headaches, amnesia, dizziness, things like that, nausea, vomiting, personality changes can also occur depending on where the concussion occurred. But nevertheless, the group that took the creatine had better outcomes with regard to every relevant effect compared to the placebo. So they had less headaches or less frequent headaches that were of less severity. They were not as dizzy, and ultimately they returned to their sport and their life faster than the placebo group, which also includes a decreased hospital stay for those that required hospitalization in this study. And again, the rationale here is that you are essentially augmenting the energy supply to the damaged area, allowing the recovery process to happen that much faster. So this is where I tend to disagree with almost everything that you might see online. So pretty much everyone is talking about the fact that the idea that you need a significantly higher dose of creatine because of the trouble of creatine to get into the brain from this aforementioned blood-brain barrier. That's what BBB stands for. Moreover, almost all of the studies that I've mentioned thus far in this video have used very high doses of creatine in their research method. So at the lowest end, there's one, I believe, that used 10, but most are using 20 to 25 grams per day in their subjects. However, what is most noteworthy, in my opinion, is the fact that 5 grams per day, the historically typical dose of creatine, over the period of 8 weeks was just as good in terms of increasing creatine brain stores as 20 grams per day for 4 weeks. This same effect is usually true in muscle as well. So if you take 20 grams per day for 4 to 7 days, you're going to have your muscles completely saturated with creatine by the end of the week. If you start taking creatine at a dose of 5 grams per day from no intake of creatine beforehand, it'll take about 4 weeks for your creatine stores to reach saturation within your muscles. So although it makes theoretical sense from a mechanism perspective when you take into account the blood-brain barrier and all that sort of stuff, the actual outcome that matters is the stored creatine concentration in the brain. And look, the whole point really is for you to take the supplement for the rest of your life to really get the whole host of benefits from it. So if you're going to take it for the rest of your life, I don't necessarily see what it matters about a short-term study if long-term studies at a lower dose tend to produce the same sort of effect. Because if you zoom a year out, you're going to see no difference. Now, another reason why a lot of these studies might be using this higher dose of creatine is because you might only have a grant for 4 weeks or 4 weeks of research funded. So you have to see these benefits soon. So, if 5 grams per day, if you're going to see the full effect at week 4, and that's when your study ends, then you've pretty much just wasted your grant money for the study. Whereas if you give your subjects 20 grams per day, you can start seeing effects, week 1 or day 1 in some cases, and you have a better chance of actually seeing a relationship between two variables if there is one. And then finally, to my knowledge, there are no long-term studies, and let's define long-term as 8 weeks, showing that lower dose creatine, lower dose meaning normal dose, really 5 grams per day, being worse for cognitive benefits than higher dose. So at this point in time, I personally would not say you need to take a super high dose of creatine for the cognitive benefits. I think 5 grams per day will do it just fine. Now, I don't think there's any harm in taking 10 to 20 grams per day. There also just may not be any benefit to doing so. So with that said, here's a quick 30-second summary of everything we talked about so far. So creatine can improve how smart you are under conditions where there are external factors inhibiting your cognitive faculties, such as sleep deprivation, oxygen deprivation, advanced age, etc. Creatine has the potential to reduce risk of things like depression. And again, I say potential because the evidence base isn't as robust as it is for cognitive function. Creatine has the, potential to improve recovery after enduring something like a concussion. And again, it's just there aren't as many studies, but the studies that are available do tend to show pretty good benefit. And finally, 5 grams per day is probably enough to give you all of these benefits, at least until a long-term study definitively shows, in my opinion, a difference between low dose versus high dose creatine, the effect of that on creatine brain stores over a long enough period of time, longer than 1 day, 2 weeks, 4 weeks, something like that. So I'm going to end this video here. Hopefully you found that somewhat helpful, interesting, or somewhere in between. If you have any questions or comments or concerns about anything that I said, don't hesitate to comment them down below and I will get back to you as soon as I can. Hope you have a good day, and I'll talk to you soon.